Okay, in this lesson we are going to continue working with tables and graphs and equations, and we're going to add one new concept. We're going to talk about if a situation is continuous or discontinuous. So the goal is that you're going to be able to identify that, and I'll explain what that means in a little bit. So go ahead and let's take a quick look at the do now. So if you take a look at the do now, the table and the equation were pretty straightforward, but then this question is, could she work 2.5 hours? And usually you can do that. You don't have to work 1 hour, 2 hours, 3 hours. Sometimes you can work fractions of hours as well. And if she did, think that one way is you could just plug 2.5 into x because x stands for hours. Or you can look at the table and realize that 2.5 is the middle of 2 and 3. So what is the middle of 16 and 24? That would be 20. But the point is that she can work for fractions of an hour. So there are many different hours she can work, not just 1, 2, 3, and 4, but 1.5, maybe 1 1/3 that she could work. And that's going to make this situation what we call continuous. But we'll talk about that a little bit later. All right, let's go over the homework real quickly. Make sure you understand these answers. Again, you're trying to figure out what mathematical operation you can do to x in order to get y, or in this case, to get from n to get c. This one was a little bit tricky. And go ahead and turn to the next page. And as I said, number 3 was something that we really haven't talked too much about. So this is the answer. If you got it, that's fantastic. If not, that's okay too. This is a tough one, so I wouldn't worry too much about it. But number 4 should be pretty straightforward. If you pull the points from the graph, and you can see that to go from x to y, you're just adding 1 each time. Hence the equation is x plus 1. All right, go ahead and turn to the next page. So we're going to look at a couple of problems like this. So I want to walk through this one so you get a model of how to do it, and then I'll probably let you try the rest on your own. So in this situation, this person is filling a pool. So just imagine you have a hose, and the hose is going into the pool, and the longer that he's pouring water into the pool, the more water is going to end up in the pool, right? So in this situation, you don't have to figure out the equation. They give you that already, right? We already have G equals 500H. So I'm going to write that over here so it's a little bit bigger. When they give you the equation, you can immediately identify the independent and the dependent variable, because the independent variable is the one that you are operating on, doing some kind of math to. In this case, we're multiplying by 500. So this is always going to be the independent variable. And the result of that operation is the dependent variable. So that means that the amount of water in the pool is dependent on the number of hours. The dependent variable depends on the independent variable. So water in the pool depends on how long you're pouring water into the pool in the first place. Okay, so let's fill out this table. It's saying that, well, here's our formula, and we can begin putting some numbers in here. So after 1 hour, there are 500 gallons in the pool. After 2 hours, there's 1,000. After 3 hours, there's 1,500. So we're adding 500 for every hour. After 4 hours, there's 2,000. 2,500, and then 6 hours we add to 3,000, and then finally for 7 hours we're up to 3,500. And you can check out the graph to see how these points were put onto the graph. All right, so let's answer the questions. We've really already answered question A, determine which variable is independent and which is dependent. So we know that the hours is the independent variable and gallons is the dependent variable, because the gallons depends on how long I was putting water into the pool. And again, we got that from the equation as well. So let's look at question B. Use what you know about independent and dependent variables to describe the relationship between the total number of gallons in the pool and the number of hours. So this is how you describe something like that. You take your two quantities and you decide what happens when I increase the independent variable, what happens to the dependent variable. So in this situation, you would write something like, as hours increase, gallons increase. So you're just talking about your two quantities and what happens when you change one, how does the other change? So as hours of putting water in the pool increases, of course the number of gallons in the pool increases. And this isn't always the same. There are many situations where you increase one variable and the other decreases. But this is how you would answer this particular question. So how can you use the table of values to confirm the equation? Well, I can just look at how I get from here to here. What rule works for every single row? And that rule is multiplying by 500. So I would say something like multiplying by 500 works for every row. And then the last point is really what we're talking about today, the last question. Does every point on the line represent a solution to the given scenario? And what they're talking about is, so in the table we have 1 and 2 and 3 and 4 and 5, but could we talk about a half hour or 1.5 hours or 2.5 hours or 2 hours and 40 minutes? And the answer is yes, because we can either use the equation or look at the graph, and at, for example, at 1.5, we can go up to the graph and kind of estimate that that's going to be between 500 and 1,000, probably at 750. So for this situation, we have a continuous scenario, okay? That means we can use fractions and decimals, and it makes sense for this problem. So the first answer is yes. And that's because time is continuous. All right, again, not everything is continuous, and we're going to see an example of that in the next problem. All right, so go ahead and turn to the next page, please. All right, I'm going to get you started with this one. I'm going to have you finish it. So again, they are giving us an equation, n equals 10p. And in this situation, this person is purchasing packages of pencils, and the equation is comparing packages of pencils to total number of pencils that are purchased. So each package has 10 pencils in it, which hopefully makes sense for this equation. So once again, like I said earlier, from this equation you can determine independent and dependent variables. Independent is what we're operating on. Dependent is the result. So this table is horizontal instead, but I'm gonna set it up for you. Here's the number of packages, here's the total number of pencils, and we'll start with 1, 2, 3, 4, and 5. Alright, I'm going to have you finish this table again. If you have one package, I'll even give you a hint here, you're going to have 10 pencils. So I want you to fill out the rest of the table, and I want you to answer the rest of these questions. So pause the video, work on these, and then come back and we'll see how you did. All right, check out these answers. Actually, I do realize I didn't fill out the rest of the table. All right, that's 20. It's not a lot of space in here. 40 and 50, obviously. Yeah, that's really messy. Let me make that a little bit nicer. That's that's not any better. My pen isn't working so well. That's the problem. That's better. All right. So let's take a look what we got here. This one's kind of silly almost. It's obvious. The number of packages increase, the number of pencils increase. We already talked about independent being packages. You can see that from the equation. You can see that from the graph because it's the x-axis. The equation tells us we're multiplying the independent variable by 10, so that helps us fill out this table. But here's the big question. Should the points be connected? For this situation, the answer is no, because I can't buy half a package. I can buy one package, I can buy 2 packages, I can buy 3 or 4 or 5, but I can't buy 1.5. So this situation would be considered discontinuous. Because there are breaks in the graph. Okay, we're not connecting with a line. There's a break in the line. That makes it discontinuous. All right, now you're going to do some practice problems with all of this. So go ahead and turn to the next page, please. So I'm going to model this problem and show you how to fill out each of these boxes, and then I'm going to have you do the other ones on your own. So let's take a look at this scenario. Lily makes a rate of $16 an hour tutoring math. The amount of time she spends with each student depends on how much help they need. The equation M equals 16H can be used to determine how much money Lily earns for the amount of hours she works. So, the independent variable, as is usual the case when you're talking about a salary, is the hours. And the dependent variable is her pay. So let's fill out the table. So we have H for hours and P for pay, let's say. And we're going to use some pretty normal values, for 1 hour and 2 hours and 3 hours and 4 hours and 5 hours. And if we fill this out, based on what's happening here, she makes 16 an hour, which is pretty good. She'll make 16 for 1 hour. She'll make 32 for 2 hours. She'll make 48 for 3 hours. She'll make 60 for 4 hours, and then 72 for 5. And I'm simply multiplying each of these by 16 because that's what our equation that they give us tells us. But you can see that's what's happening here. All right. So coming around to question 4. Now notice on this graph, there's no numbers, but we're going to keep this simple. You're going to use the numbers straight out of the graph. So for example, on the x-axis, which is going to be our hours, which you should label, we're just going to make each one be 1, 2, 3, 4, 5, and 6 if you want. And on the y-axis, which is pay, we're going to use the numbers from the table for our lines. So this is going to be 16, and this will be 32 and 48. This pen is driving me crazy. And this will be 60, and this will be 72. That way we can graph it really easily. So I know 1 hour goes with 16, 2 hours goes with 32, 3 hours goes with 48, 4 hours goes with 60, and 5 hours goes with 72. And then we come to the big question. Should we join the points on the graph? Should we connect them? Why or why not? Well, could she tutor for an hour and a half, or 2.5 hours, or 3.5 hours? And the answer to that is yes. Time is continuous. That's just a no-brainer. So you could connect these points. Okay. So the answer here is yes. You could say she can tutor a fraction of an hour. And so keep that in mind. Time is one of the easier ones to think about. All right, so read the scenario, figure out the independent and dependent variables, create a table, create the graph, and then decide if it's continuous or discontinuous. All right, go ahead to the next page, please. All right, I'm going to let you do this one from start to finish, so go ahead and pause the video and fill in all of the answers to the squares, and then come back and see how you did. All right, check out these answers. Again, I think it's a pretty straightforward situation, but once again, here the answer is no. You do not connect them because the farmer's market occurs every week. Nothing happens between those weeks. Nothing is sold, so it's only sold at 1 week, sold at 2 weeks, sold at 3 weeks, but there is no 1.5 or 2.5 or 3.5. The farmer's market only occurs once a week. So you would not connect this. This is discontinuous. All right, go ahead and turn to the next page, please. All right, go ahead and do this problem. Pause the video, complete all the boxes, then come back and see how you did. All right, check out the answers here, and once again, these should be pretty straightforward, and this is a situation that is not continuous. You don't connect these because you can't buy half a package of buns. Stores won't let you do that. So that makes that discontinuous. All right, one more problem. Go ahead and turn to the next page, please. All right, one more situation. Go ahead and work on this. Pause the video and then come back and see how you did. All right, here's the final answer. So here, independence minutes in gallons. I changed things up a little bit just to make the numbers look nicer. You could do it differently, but I decided to go with 2, 4, 6, 8, and 10 for my minutes because my equation is dividing by 2, so I just want my numbers to work out more nicely. So that gives me 1, 4 divided by 2 is 2, 6 divided by 3 is 3, and so on. And that made my graph a lot easier to do as well. If you did 1, 2, 3, 4, 5, you'll still be able to get numbers that you can work with in graph, but it'll be a little bit different than this. And once again, this is a continuous situation, okay? It deals with time, minutes, so we can look at 1.5 minutes or 3.5 minutes or 1 minute and 40 seconds. Time is continuous, so you will connect these dots. All right, if you are viewing this in class, there's going to be an exit card coming towards the end. So if you're done with this and we're not quite to the exit card yet, you can work on your homework. Let me know if you have any questions.